Synthesis and decomposition reactions are difficult to classify because some of the reactions are going to be considered redox reactions. Some of the reactions can be considered metathesis reactions. They don't have one set category that they fall into. Synthesis reactions are going to be where one compound is being formed as a product from multiple atoms or compounds as reactants. Decomposition reactions, you're going to be able to identify them as having only one reactant, and it's going to break down into two or more elements or compounds. In a sense, you can basically think of synthesis and decomposition reactions as opposites. So the reverse of a synthesis is a decomposition and vice versa. Let's look at the synthesis reactions. The general format is that you're going to have two, possibly more compounds or elements on the reactant side, and you are going to end with one product. Let's look at an example. We have ammonia gas and hydrogen chloride. These will react to form ammonium chloride. Another example of a synthesis reaction would be calcium oxide and water. If you place the calcium oxide in the water, it's going to make calcium hydroxide. Now, these reactions would be difficult to predict, and you're not going to have to. The only reactions that you're going to have to predict are those that have elements only as reactants. And when you have elements only as reactants, you can only do one thing: bring them together to form a compound. So in this example, we've got sodium and chlorine. If we bring these two together to form a compound, you're going to form sodium chloride. Again, notice that we have dropped the two on the reactant side off of the chlorine because we need to balance the charge and write the formula out properly. Another example would be magnesium reacting with sulfur. The product of this is going to be magnesium sulfide. And our third example is aluminum reacting with oxygen. Again, all you're simply going to do is bring these two elements together to form a compound. You write out the formula balanced correctly and then balance the reaction. To illustrate the fact that synthesis reactions don't necessarily get classified as one or the other, we'll see that the first two reactions that we looked at, all of the oxidation states for the elements stayed the same. That means that they are a metathesis. The last three reactions we just looked at, these are going to be redox reactions. We're starting off with all zero oxidation states on the reactant side, and on the product side, they now have oxidation states of whatever they're assigned on the periodic table.